Cardiac murmurs are classified into three groups based on their timing: systolic murmur, diastolic murmur, and continuous murmur.
Hello, and welcome to the Habib Heart channel. The cardiac cycle has two main phases, the systolic phase and the diastolic phase. In the systolic phase, the ventricles contract and blood is pumped into the aorta and pulmonary artery. In the diastolic phase, the mitral and tricuspid valves open and blood flows from the atria into the ventricles. If a murmur is present only during the systolic phase, it is called a systolic murmur. If it is present only during the diastolic phase, it is called a diastolic murmur. And if the murmur is heard during both systole and diastole, we call it a continuous murmur. Systolic murmurs are murmurs and sounds that occur during ventricular systole. During systole, specifically in the heart, the mitral and tricuspid valves are closed, while the aortic and pulmonary valves are open, respectively. Normally, since there is no gradient between the areas before and after the valves, blood flow does not become turbulent, and for this reason, no murmur or sound is heard. But if we have aortic valve stenosis or pulmonary valve stenosis, it causes a pressure gradient or a jump in the gradient before and after the valve, and this leads to the blood flow losing its laminar state and becoming turbulent as it passes through the valve. And as we mentioned, it is the turbulent blood flow that creates sound, and we can hear this sound as a murmur with a stethoscope. Therefore, the turbulent blood flow and the murmur caused by aortic valve stenosis and pulmonary valve stenosis are both heard during the systolic phase. In the systolic phase, as we mentioned, we expect the mitral and tricuspid valves to be closed. However, if there is insufficiency of these valves, when the left ventricle contracts, some of the blood flows back into the atria. Because during systole, there is a gradient between the ventricles and the atria. During systole, the blood pressure in the left ventricle is 120 mmHg, while the pressure in the left atrium is less than 10 mmHg. Therefore, if there is a connection between these two chambers, due to the significant pressure gradient, the blood flow becomes completely turbulent and produces a loud murmur. During systole, the pressure in the right ventricle is also about 20 mmHg, and the pressure in the right atrium is less than 5 mmHg. For this reason, mitral regurgitation and tricuspid regurgitation also result in systolic murmurs. The next condition in which its murmur is heard during systole is VSD, or ventricular septal defect. In these patients, there is a defect or hole in the wall between the left and right ventricles, which causes blood to flow from the left ventricle into the right ventricle during systole. Because during systole, the pressure in the left ventricle is 120 mmHg, while in the right ventricle it is 20 mmHg. And since the pressure gradient is very high, the murmur caused by VSD will be very loud and of high intensity. Why don't we hear the VSD murmur during diastole? Because during diastole, the pressure in the left ventricle is 0 mmHg, and the pressure in the right ventricle is also 0 mmHg. So practically, there is no gradient between the left and right ventricles during diastole. Therefore, systolic murmurs such as aortic stenosis, pulmonary stenosis, mitral regurgitation, tricuspid regurgitation, and VSD heard in the interval between zone and stu, which corresponds to systole.
If you found the video helpful so far, please like it and share it with your friends. And if you don't want to miss my upcoming videos, please subscribe.
But now, diastolic murmurs? What happens during diastole? During diastole, the mitral and tricuspid valves are open, but the aortic and pulmonary valves are completely closed. That's why blood flows from the atria into the ventricles. In normal individuals at the beginning of diastole, there is no pressure gradient or difference between the atria and the ventricles. Mitral valve stenosis causes the pressure in the atria to rise usually above 15 millimeters of mercury, while the diastolic pressure in the ventricles is less than 5 millimeters of mercury. This means that there is a pressure gradient between the atrium and the ventricle, and this very pressure gradient causes the blood flow that is supposed to move from the left atrium into the left ventricle to become turbulent. This turbulence leads to the production of a sound or murmur. Therefore, valvular diseases that lead to a diastolic murmur include mitral stenosis and tricuspid stenosis. During diastole, the aortic and pulmonary valves are closed, so There is no connection between the aorta and the ventricular chambers. But in patients who have aortic or pulmonary valve insufficiency during diastole, blood flows from the aorta into the left ventricle and from the pulmonary artery into the right ventricle. During diastole, the blood pressure in the aorta is about 80 millimeters of mercury, while the pressure in the left ventricle is less than 5 millimeters of mercury. There is a pressure gradient between 80 and 5, and for this reason, the blood flow from the aorta into the left ventricle becomes turbulent, and this turbulence leads to the murmur being heard. So the next condition that leads to a diastolic murmur is as follows: aortic regurgitation or aortic insufficiency. The diastolic pressure of the pulmonary artery is about 10 to 15 millimeters of mercury, and the diastolic pressure of the right ventricle is less than 5 millimeters of mercury. In a patient with pulmonary insufficiency or regurgitation, blood flows from the pulmonary artery into the right ventricle during diastole, leading to turbulent blood flow, and as a result, the sound of pulmonary regurgitation can be heard. Therefore, the diastolic phase occurs after the closure of the aortic and pulmonary valves, that is, after the stu sound is heard until the next zone. We refer to the interval between stu and zone. The diastolic phase, as well as diastolic murmurs and bruits, are also heard during this interval. And finally, the last group are continuous murmurs, which are murmurs that can be heard during both systole and diastole. The reason for this is that there is a pressure gradient between the two chambers during both systole and diastole. The first disease that leads to a continuous murmur is PDA, or patent ductus arteriosus. In these patients, there is an arterial connection between the aorta and the pulmonary artery, meaning these two are connected, and this causes blood to flow from the aorta into the pulmonary artery. This is because the blood pressure in the aorta is 120 over 80 mmHg, while the blood pressure in the pulmonary artery is 20 over 10 mmHg. Therefore, as you can see, there is a pressure gradient both in systole and diastole, and for this reason, the murmur caused by PDA, or patent ductus arteriosus, is a continuous murmur. Other diseases that can lead to a continuous murmur include the following: rupture of the sinus of Valsalva, branch artery stenosis, and arteriovenous fistula. Therefore, cardiac murmurs are classified into three groups based on their timing: systolic murmur, diastolic murmur, and continuous murmur.